Hello students, we are going to start the syllabus of TYBSc class. We'll see first the paper number 2, paper name is Theory of Estimation. We'll start with the unit number 1, unit name is Point Estimation and Properties of Estimator. We'll see some basic definitions. First, the first definition is population. The definition is a collection of objects under study is called population. In other words, the universal set of objects having some common property is called population. Okay, population means a group of individual observations in which all the observations has some common property. Okay, for example, height of students in TYBSc class. Okay, we measure the height of all the students of TYBSc class and consider this group is called as a population. Second definition is a sample. The definition is a finite subset of a population is called sample. Sample is a finite subset of this our population. The number of observations in a sample is called sample size. Means how much observations in the sample, this number is called as a sample size. For example, consider a population of size 10 of marks of students. 3 observations are drawn randomly from population, then such set is called sample and sample size is 3. Okay, means we consider a population of size 10 of marks of students and 3 observations are obtained from this population, then the set of 3 observation is called sample and sample size is 3. Next definition, we can see in this picture, this is population, target population, and we obtain the sample from this population. Okay, then this is a population and sample is a subset of population. Okay, let's see next definition. Next point is parameter. The definition is the unknown constants of population or distribution are called parameters of population or distributions. Means population has many different unknown constants like mean, mode, median, variance, etc. Then these constants are called parameters of the population or parameters of the distribution. Okay, for example, let fx theta be the PDF or PMF of a random variable capital X having unknown constant theta, then theta is called parameter of the distribution. We consider theta is any parameter of this distribution. Okay, let's see next definition. Next definition is a sample statistic and sampling distribution. Okay, the definition is any function of sample values. Any function of sample values is called sample statistic. We can take any function, for example, summation of observations, sum of square of observations, like that. Sample statistics are constant for a given sample but differs from sample to sample. Hence, it is a random variable having certain distributions. Okay, sample statistics is same for a given sample but differ from sample to sample. Hence, it is a random variable having some distribution which depends upon distribution of the population, okay, from which sample is drawn. Thus, the distribution of the sample statistic is called sampling distribution. Okay, means the distribution of statistic is called as a sampling distribution. Next definition is a parameter space. Parameter space, the definition is a set of all admissible values of a parameter of the distribution is called parameter space. Okay, means a set of all possible values of parameter. Okay, such a set is called as a parameter space. This parameter space is denoted by script theta. Let us see the example of parameter space. The first example, a random variable capital X follows exponential distribution with parameter theta. Then the PDF of X is the PDF. We know that the PDF of exponential distribution is fx theta is f of x is equal to theta into e raised to minus theta x. Theta greater than 0, the range is theta greater than 0 and x is greater than or equal to 0 otherwise. Okay, in this PDF we can see that the range of theta is theta greater than 0. Okay, then our parameter space is depends on these values of theta. Okay, then the parameter space is the set of script theta is equal to set of all values of theta such that theta greater than 0. Okay, we take all the values of theta from this set. Okay, let us see another example. X, random variable x, follows binomial distribution with parameter n and p. Then the PMF of binomial distribution is ncx p raised to x q raised to n minus x. The range of x is equal to 0, 1, 2 up to n. N is greater than 0 and p is lies in between 0 to 1. P plus q is equal to 1, 0 otherwise. Then the parameter space is the script theta is equal to set of values of n and p such that n is greater than 0 and p is lies in between 0 to 1. Okay, let us consider the third example. If x follows normal distribution with parameter mu and sigma square, then the parameter space is we know that the in the normal distribution the range of mu is lies in between minus infinity to infinity and sigma is greater than 0. Therefore, the parameter space script theta is equal to set of values of mu and sigma or mu and sigma square such that mu is lies in between minus infinity to infinity and sigma greater than 0. Okay. Let us see the next definition, statistical inference. Okay. The description is statistical inference is the process of extracting some remarks, okay, or conclusions about one or more parameters of the distribution. Okay, that is, the statistical inference is the process of extracting some remarks or conclusion about parameters. A sample is usually taken to study the characteristic of the population, that is, parameter of the population is estimated by using results of sample. Such procedure is called statistical inference. Okay, the statistical inference is divided into two parts. The first part is parametric inference and second part is non-parametric inference. These are main branches of statistical inference. Let us see first parametric inference. In parametric inference, the distribution of population is assumed to be known and parameters are unknown. Okay, then such inference about parameter is called parametric inference. Okay, the main part is that in parametric inference, the population is assumed to be known or it is known. Okay, and but parameters are unknown. Okay, in non-parametric inference, the distribution of the population and parameter both are unknown. Okay, if the distribution is unknown and parameter is also unknown, then this inference belongs to non-parametric inference. And if distribution is assumed to be known or it is known and parameter is unknown, then this inference belongs to parametric inference. Okay, the parametric inference is also divided into two parts. First part is theory of estimation. This is our paper number 2, and second part is testing of hypothesis. This paper is going to teach in next semester. Okay, now theory of estimation is also divided into two parts. First is point estimation and second is interval estimation. Okay, then let us see the first part, point estimation. Okay, the point estimation, let us see this. Let x1, x2 dot 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 xn be a random sample of size n from a distribution having PDF or PMF fx theta, where theta is unknown parameter. Okay, this is the sample from a population having PDF fx theta and theta is unknown. Then the method of estimating the value of unknown parameter theta using sample statistic t, t is equal to t of x1, x2, xn, means it is any function of sample values, which is a point on the real line. Okay, we obtain a statistic which is a point on the real line. Such method of estimation is called point estimation. Okay, the next definition is interval estimation. Let us see the description. Instead of estimating the value of parameter by using sample statistic, we obtain an interval or a set of values. Okay, means in point estimation we estimate or we obtain a single point, but in interval estimation we obtain an interval. Okay, or a set. The set is determined in terms of observations such that the actual value of parameter may be likely belong to the set. Okay, means the parameter, the value of this parameter is belongs to that set with some surety. Such set is called as a interval. Usually the set is taken as an interval. This process of estimation is called interval estimation. Okay, we'll stop right now. Okay, thank you.